In this video, we're going to conduct a chi-square test for homogeneity of proportions. So definition. In a chi-square test for homogeneity of proportions, we test whether different populations have the same proportion of individuals with some characteristic. So we're going to have different populations, and we're going to be checking to see, are the proportions of individuals with this characteristic the same? Are they homogeneous? Or are they different? So a test for homogeneity of proportions. Our null hypothesis is going to be that P1 equals P2 equals P3 equals P4 equals P5 and so on, depending on how many different populations that we're looking at. The alternative hypothesis will be that at least one of the population proportions is different from the others. Now, the procedure for performing a test of homogeneity are identical to those for a test of independence. So in other words, there's really no difference here. Conducting a test for homogeneity of proportions is exactly the same as conducting a test for independence. So our process is going to be the exact same. So let's take a look at an example. What's in a word? In a recent survey conducted by the Pew Research Center, a random sample of adults 18 years of age or older living in the continental United States was asked their reaction to the word capitalism. In addition, individuals were asked to disclose which political party they most associate with. Results of the survey are given in the table. So we can see the results here. So Democrats, 235, have a positive reaction to the word capitalism. Independents, 288, have a positive reaction. Republicans, 256, have a positive reaction. A negative reaction, 264 Democrats, 266 Independents, 157 Republicans. So, question A, does this evidence suggest individuals within each political affiliation react differently to the word capitalism? Use a 0.05 level of significance. And then B, construct a conditional distribution of reaction by political party. So the first thing that I'm going to need to do is figure out the expected values. But what I'm going to do for this problem is I'm going to use technology to conduct this hypothesis test. But first of all, we need to establish our null and our alternative hypothesis. So our null hypothesis is going to be that the proportion of Democrats equals the proportion of independents equals the proportion of Republicans. So in other words, the proportion with, say, a positive reaction is the same for Democrats, independents, and Republicans. Our alternative hypothesis is going to be at least one proportions different. So that's our alternative hypothesis. Now, we're told to use a alpha equals 0.05 level of significance. So we're going to do that. And if I'm going to use the classical approach, then I'll need to find the critical value. Now in this table, this is again just like a contingency table, we have 2 rows and 3 columns. So our degrees of freedom is going to equal 2 minus 1 times 3 minus 1. Well, 2 minus 1 is 1, 3 minus 1 is 2, and so that is 2 degrees of freedom. We have only 2 degrees of freedom for this problem. So I have a chi-square distribution with 2 degrees of freedom. And alpha is equal to 0.05. So if this is alpha equals 0.05, I would need to find the critical value so that I can compare my test statistic to it when I find my test statistic. So if I use the chi-square table, I have 2 degrees of freedom and 0.05 is my level of significance. So that's going to be 5.991 is my critical value here. This is my chi-square sub alpha right here. Now, I'm going to use technology, as I said before, to conduct this test. So I'm going to use my calculator. So I'm going to bring in my calculator. I'm going to go to matrix, and I'm going to edit matrix A. This time we have a 2-row by 3-column matrix, and I'm just going to enter this data. So 235, 288, 256, 264, 266, 157. So I have that data in my calculator. I'm second quit to go back to the home screen. Now I'm going to do stat and test and go to chi-square test. So that's option C. My observed values are in matrix A. The calculator will put the expected values in matrix B. If I calculate, chi-square naught is going to be 20.598. If I round to 3 places, the p-value is 3.3669 times 10 to the negative 5. So my test statistic, chi-square naught, is 20.598. My p-value is equal to 3.3669 times 10 to the negative 5. So that would be 0.000033669. So if I round to 4 places like usual, that p-value is 0.0000. Now, if I use the classical approach, the test statistic 20.598 is going to be way over here to the right. That's going to tell me to reject the null hypothesis. If I use the p-value approach, well, 0.0000 is definitely less than 0.05, so that's also going to tell me to reject the null hypothesis. So I'm rejecting that the proportion of Democrats equals the proportion of independents equals the proportion of Republicans, and I'm concluding that at least one of the proportions is different. So at least one of the political parties has a different reaction to the word capitalism than the others. Now, so I've used my calculator to do that. I could have used StatCrunch to do that as well. I'm not going to, but I could have. And we could have also have done this by hand. Again, I'm not going to, but we could have. We know the method. Now, question B, we want to construct a conditional distribution of reaction by political party. So, in other words, we want to determine what the reactions are. So to do this, I'm going to need to know the totals of each of these columns. So I bring back my calculator in. If I add up 235 plus 264, that is 499. So there were 499 Democrats. 288 plus 266, there were 554 independents. And 256 plus 157, there were 413 Republicans. Now again, what I'm going to do is I'm going to find the positive and the negative reaction for each group. So I'm finding a conditional distribution of reaction by political party. So if I take 235 divided by 499, that is 0.471. And if I take 264 divided by 499, that is 0.529. So this is 0.471 and 0.529. So about 47% of Democrats had a positive reaction, and about 53% of Democrats had a negative reaction to the word capitalism. Similarly, 288 divided by 554, that is 0.520 if I round to 3 places, and 266 divided by 554, that is 0.480. So 0.520 and 0.480. So about 52% of independents have a positive reaction and 48% have a negative reaction to the word capitalism. And if I take 256 divided by 413 and 157 divided by 413, that is 0.620 and 0.380. So 0.620 and 0.380. So about 62% of Republicans have a positive reaction and 38% of Republicans have a negative reaction to capitalism. So this is our conditional distribution by political party. So this does support what we concluded. At least one's different. In fact, it looks like maybe they're all different. 47% versus 52% versus 62% have a positive reaction, and then likewise negative reaction, 53 versus 48 versus 38. So it does look like there is a difference as we concluded with our test. So this concludes our test for the homogeneity of proportions. Again, it works just like the test for independence, not a difference in how the test is conducted, but just a difference in the concept.